Hello and welcome, everybody. Thank you so much for joining us today for the fourth in our 6-session series, Day 1 and Beyond, which takes you through a series of topics and activities related to building out on Oracle Cloud. If you are new to these events, we are hosted on Cloud Customer Connect, which is Oracle's community forum for end users. I'll be dropping some links in the chat throughout the presentation today that lead you back to those CCC forums. So if you haven't already, we invite you to create an account, join in the discussions, look for more upcoming events. My name is Kenna Kettrick. I'm the program manager with the OCI Go-to-Market team. And today I am joined by Larry Beausoleil, Cloud Engineering Senior Enablement Manager, and Jeremy Walker, Master Principal Cloud Architect. And today they're going to be focusing on Operations Quick Start. Before I hand things over to our presenters, I do want to run one quick poll. For those of you who've been with us before, this will be familiar. We build all of these fundamentals and also our Thursday weekly deep dives with you, our users, in mind. So I always like to hear what folks are interested in general, what kind of things you want to focus on, and that helps me to build out future events. Speaking of, we do have a second event this week on Thursday, August 12th. We're hosting Karan Vora to introduce and demo our new OCI Bastion service, which is a fully managed security service that provides restricted access to your private endpoints in Oracle. I'll drop a link to that registration page in the chat if you'd like to join us in a couple days. And I'm also going to drop a link to a survey that we're running with OCI customers. We really appreciate your opinions and value your feedback. So if you have a couple moments later today to drop your opinions in that survey, we always love to hear that. And our usual reminders, please use that Q&A box at the bottom of the screen at any point throughout the presentation today for your questions. We'll have some time for Q&A at the end as well. And we'll be recording. So if you have folks you think might be interested later on, there will be replays and I will drop links to that as well. All right, that is quite enough from me. Go ahead and take it away, Larry.
Awesome. Thank you, Kenna. And welcome everybody to Day 1 and Beyond with Cloud Operations Quick Start. Again, I'm joined today with Jeremy, and we're going to take you through this epic journey today. Operations it's a fun conversation. We've talked about a fair amount of pieces in this journey so far. We've talked about governance and business operations. We've talked about our networking portion. We've talked briefly, we delved into networking pretty intensely last time, so it's something that can definitely watch the recap. But we covered a fair amount. Today we're going to cover shared responsibility model again. This is something that I really like to highlight every time we talk about this, because it is something that when you move to the cloud, that you have to consider this piece. You have to make sure that you're deploying and understanding where the line is set and what you need to deploy versus what the vendor needs to take care of, so that you can build that into your day-to-day operational model, and make sure you understand what risks that you have to be more concerned about, and that's all part of kind of the operational journey. And we're going to understand a little bit of operations on Oracle Cloud Infrastructure and what that looks like. You may have heard a term called infrastructure as code that's out there, and that's something that we're going to talk briefly about and what Oracle has to provide for that specific piece in cloud operations. So we're going to learn how to use and deploy tools on Oracle Cloud Infrastructure and management of resources at cloud scale. Because one of the biggest things when we start expanding to cloud, we're not just managing one or two servers here. We are going to a completely different setup, and I guess I shouldn't say completely different, because if you're using virtualization on-prem and automating your deployments, it's a matter of learning the terminology and how you can utilize and use cloud to scale to your advantage. Trying to reduce latency by getting close to customers, all these things can be done with cloud. So we'll go to the shared responsibility model. This is something that we have on-prem, and everybody is, probably aware of this. This is like even at home, at a data center, anything like that. We have this. We're taking care of everything. We're running you're running the wires. You're doing everything. When you start getting into IaaS, PaaS, and SaaS, it progresses up, and so it kind of reduces how much effort you have to put in so you can focus on the truly important parts of your application or your business. So complete cloud services, this is something that we have in kind of our journey. So we have a complete stack that we're able to provide. Today, we're going to focus on kind of our infrastructure as code piece and just kind of our operations. And so this is where we're going to kind of sit today. So infrastructure as code and just kind of understanding what that looks like, understanding some of the monitoring, logging. And I know that those link to like governance and administration under this pillar, this portion, but we're still going to kind of talk about those because those are part of our operational journey. So let's kind of progress into this. So Jeremy, before this call, we kind of discussed this, about how massive and expansive, going into a cloud vendor can be. And I think this map kind of alludes to that and gives us the landscape that we're going to deploy into. What's your like brief thoughts on this? Like this is something that, if I deployed into Phoenix, how does operations, how does some of the stuff that we're going to talk about today help me?
Yeah, definitely. Because when you go cloud, you inherit that cloud scale. You'll hear that term over and over again. And that's where this operations, where infrastructure as code, where cloud ops, as you mentioned, we're managing these resources from start to finish in a manageable way with little overhead really becomes important. Because looking here at Oracle's footprint across the planet, it would become easy, like you said, if we put resources in Phoenix and we have a DR in San Jose, but we also we have customers perhaps in Europe, and so we want to put some resources there to reduce latency, increase their experience with our product or maybe even our employees. How do you manage all of that? On-prem, typically a typical enterprise, you'll have a local data center, a colo in a couple of places, maybe a few scattered here and there on closer to customers. But with cloud, you have all of this that you have, one, the opportunity to use, but also like you just mentioned, the obligation and the responsibility to manage. And so that's where it becomes important to bring in these tools. The infrastructure as code is we're going to go into, and then also some of the other tools that we'll mention that OCI provides to really bring this home to where you can manage it with the small DevOps team or even a smaller cloud ops team that can, with just a few people, manage thousands and thousands of resources in the cloud.
Yeah, definitely. And I don't want to dive into it too deeply, but you brought up another term there, DevOps, and that's something that like we are focused on the operational side, but like you have those two teams working side by side. You have a development team and an operations team that is going to closely work on deploying this. So it's something that as we continue on, we start talking about, what is this cloud operations piece that we're discussing today? We are focused on, we're building something, we have to configure it. We do have to monitor what's going on. And I know this may sound strange or people are like, why do we need to do that? But we do need to monitor the monitors, especially when it comes to applications, because depending on how it's configured, you could have something, your server that is actually monitoring what's going on that is failing and giving you false positives or false negatives to the application's view. And then we need to make sure it's protected. So talking about security and how we configure that, we need to secure the application, and then we have to have governance around this. Where are we storing it? What's going on with our actual data? And this can all be done with how we deploy our application.
Yeah, and you mentioned it right there. Is some enterprises already have experience with virtualization using VMware, or maybe a Microsoft solution running virtual VMs. But in a typical on-prem environment, and what most enterprises have in place, they have a network team that manages all of the network space, the network segmentation, encryption in flight, connections from one data center to another. You have a knock with ops teams and people ready to jump up and jump on the mainframe if a job fails or if there's an issue. You have security teams that monitor all of it. I mentioned that DevOps term, and I should have defined it a little bit better. But with this new cloud operating model, you're going to have developers increasingly in the enterprise space. You have developers that are writing application code, but alongside that application code, they're writing the deployment code, they're writing the network connectivity code, they're writing the security aspects that govern their application. Some of this not extreme, but the serverless and beyond cases, they're writing all the way from customer experience back to database, back to network. And so that's where it becomes really critical that all of those things that we showed before, the monitoring, the security, operations, it comes down to how well are you governing your operations with scripting and automation, which is what we're going to. So that's where we're finding ourselves today with cloud operations.
Yeah. And something that I know we've talked about before and kind of talked about before getting into operations was I remember when I first started becoming like a system administrator and, doing some of this stuff. I'm a lazy sysadmin, and I'm not saying that in the fact that, I'm not, you're not working, but it's something that when we getting into the idea of like scripting and some of the other tools that we're talking about today is if we have to do this more than once, take the time to make a script like that. That is one of those pieces that I know a lot of sysadmins are going to say, well, if it takes me a minute, should I take the 4 hours to automate it? And in some cases, it can be beneficial because scripting gives you a little bit more consistency. Because we've seen, I've seen in the industry where manual process, you deploy something to 30 machines and you do it manually, you may have 30 different configurations on those machines. If we start scripting it, creating, a central repository and start deploying that, now we've added a level of consistency that if we did our proper checks on that script, that it's going to deploy it correctly, or we have either 30 correctly deployed or 30 incorrectly deployed. So there is some risk to that if we don't test our script. But scripting is going to make it easier and quicker to manage those 30 resources than is to go one by one. And when we start, we talked about the cloud scale here. If you're deploying to 2 regions and you start getting into 50, 100, 200, 300, 1,000 instances or 1,000 compute level resources, and this could be anywhere from running a function to running a containerization. Like there's a lot of things that need to be scripted as we kind of progress through this journey. And after scripting, then we get into the idea of full automation. And this is kind of the starts to full automation. And a big term when you start thinking about that is continuous integration, continuous deployment. So one of the pieces that we're going to break out today is the idea of using Terraform. And Terraform is going to be very beneficial. So Jeremy, Terraform, it's infrastructure as code, right?
Right.
That's what we're looking at today. So how is Terraform going to help me on this journey of making my deployments better overall? I mean, what's it going to do for me that I wasn't able to do before?
Yeah, and that something that many system administrators and network administrators, this fear that they have going to cloud is this loss of control. When you're on-prem and you have the wires in your hands and you can see it go into a plug, or you have your Palo Altos or your NetScalers right there, you know where they are, you know how they're behaving, they're yours, they're in your environment. And that loss of control is very understandable, but Terraform infrastructure as code, this combination of automation with security and configuration is an attempt, a very successful attempt, as I think it's been proven up to this point in just operating in the cloud in general, in regaining that control. It allows you to define, to establish standards, to script out and put into place exactly what you want to see as a resulting after the script is executed. So if you want a network topography that has a certain shape, size, configuration with specific ingresses and egresses, you can establish that in Terraform, build it, and do it again, and repeat it in several different places. And then if there's a change to it, the big thing here, and we'll go into this a little bit more later, is if you change it once, it's reviewable, it's auditable, it's controllable, and it's not just someone going through an interface and clicking. It's not someone reaching up and pulling a wire. So Terraform is just as a scripting language that HashiCorp came up with. Is written in HCL. So it's kind of JSON looking language that allows you to declare and describe the exact state of your environment and then execute it. And it takes care of all the underpinning scripting and all the grunt work to establish that state in your cloud environment.
And kind of continuing on that, I think the benefits I see in Terraform from what you're describing, it is somewhat vendor agnostic. Like Terraform it's an open source product that's utilized here. It's something that you can, if you have multiple cloud vendors, you don't have to relearn how to write Terraform. The only thing you have to understand is the different providers that you need to pull in. So it's, if we think about Python or coding or anything like that, it's basically just pulling in a module to say, okay, I need to talk to Oracle or I need to talk to another cloud vendor at that time to do what I'm trying to do. And so it gives you a little bit more, ease of use and functionality. So you're not trying to learn vendors, different tools to deploy wherever you go.
That's exactly right. And I have several customers I'm working with now that's what they love about Terraform. Many enterprises have this hybrid cloud scenario where they have some data in one cloud, some data in another, some applications in another. And some of those cloud providers have these vendor specific notations or languages to build it out, to build out their ecosystem. With Terraform, it can speak to each of those cloud environments, like you said, agnostically. So you can have standards across every environment that are maintained in a single repository, in a single format, so that you don't have to have one-offs for every single environment that you build.
Yep. All right, let's talk more about Terraform. Well, with with a couple other components kind of mixed in there. So monitoring, logging, and notifications. I'll get into this last little one in the corner in a second, but along this journey of using like infrastructure as code and kind of deploying, we still have to monitor, and I talked about that at the beginning. We still have to look at what's actually happening, because just because we deploy something doesn't mean it's going to function the way we expect when we start scaling to 1,000 resources. You start deploying code and you can run into memory leak issues. You can run into, this is something deployed because of a patch, and so you're having performance issues. So how do you track that? So we do have a way to visualize what's going on. You can monitor everything. You can create dashboards. You can do that. Logging, we're collecting what's going on, because at the end of the day, we do have to run, every customer, and when you're meeting compliances and stuff, you're going to have audits. You're going to have, you have to look at security events. You have to look at everything that's happening in the account. And then notifications. So when we're using these things, we can send out notifications, alerts, and this can integrate into like Slack, PagerDuty, and other third-party apps like ServiceNow has a way to kind of integrate with some of the notifications, so you could generate a ticket, so that when you deploy your application, you set up your monitoring, and you can use Terraform to do this. This is not something that has to be a manual process, because you've built your application, you've written it out in Terraform to say, I want an alert on my CPU. and I want these metrics around it, and I want this notification, to tell me what's going on. And so this can be automated to make it easier to replicate, especially when you start expanding from region to region. Now, the final one in the corner is Resource Manager. And Resource Manager, what this is going to give us when we look at Terraform is the capability of, if you are new to Terraform, if this is your first time ever hearing the word Terraform or the automation portion, you can pop into the console, use Resource Manager, and this is going to give you some of the controls. This is going to make it easy for infrastructure as code, and make it easy because you can grab some of our standard Terraform templates, deploy it, test it out. Now, I want to put like a huge disclaimer around any Terraform template that you just grab from like Stack Overflow, GitHub, any sort of like public documentation. Please keep in mind that even if you grab something that is from a known source, you still want to vet it, because this goes back to understanding security, understanding all of the other components about it. You still want to understand what's getting deployed into the account, because Terraform itself may not cost, but the resources you're deploying can cost. And so you have to consider, is this the right level of deployment for my application? Am I deploying a bare metal server that's maxed out and going to have a higher cost, or am I deploying just what I need for this point, and a small n-tier architecture that has maybe one instance, a load balancer, a couple of things, because you do have to consider those when you deploy Terraform. And I've seen this happen where a Terraform script got deployed, and there was an auto scaling configuration, and the application just started scaling drastically because there was a slight typo in the code. So keep that in mind, that there are ways to test this code before you deploy it, and we'll talk about that when we get into the next piece. So this is Resource Manager. So Jeremy, you want to walk us through a little bit of Resource Manager here? Terraform as a service and that kind of piece of this. Define configurations. What the benefit of Resource Manager is.
Definitely, because this is something that I really like as a service within OCI. I would like to think, though that I know from experience it's not the case, I would like to think that most enterprises have something of a deployment pipeline, development pipeline, an automated system for configuration into their environments. Where that's not the case, or even in some cases where that is the case, but you need a little bit more, Resource Manager steps in. It takes care of a lot of the heavy lifting that comes along with a deployment of an infrastructure. It takes care of managing the state, which, if you're not familiar with Terraform and the state, the idea of state is what does the desired appearance of your infrastructure look like, and how do you want it to look? If you make changes, you change the way that state looks. Why that's important is if you're building out a DR or you're building out a development environment, you can take that state that you have in production and replicate it in a development or in a DR without having to manually go through and create every resource that you have. So what the Resource Manager does is give you that platform to put that Terraform on, to establish that state. And then it also keeps execute that Terraform code, the full stack lifecycle, and it gives you that platform that you can build from and just start developing. You don't have to go out and get build servers like Jenkins or Hudson or something like that. You can run it inside of the cloud ecosystem. Now, from this, you have all stages of development. You have that testing, like what Larry was mentioning earlier. You can test. You can develop a stack. You can progress on it as you make changes, and then when you're happy with it, you can deploy it into your environment, and then you have that state, and then have your test and your deployment pipeline in the background. The really cool part about this, I'll say one of the many really cool parts that I like, is the last part, the destroy, the cleanup. because that's a lot of what happens with larger ecosystems in the cloud. Is if you do it by hand, you forget about that one-off server you spun up in that random region, or you have a network setting that you added solely for one POC that you did. With this, with Resource Manager and with Terraform in general, you have all of those resources defined. When you're done with them, you can destroy them cleanly without having any virtual technical debt hanging around in the cloud that could either cause security vulnerabilities, cost money that you're not benefiting from. So this whole life cycle of the stack is managed within Resource Manager. I can actually show it pretty quickly right here. I have a demo ready to go, and we can kind of step through it to see how it looks on the back end, and then how you interface with it, and then what it looks like when it comes out.
Right before we go to sharing that, Jeremy, one of the things that, you talked about destroying the stack and everything, and how everything's kind of linked to Terraform. I think one of the neat things about Terraform now is you can actually create your environment manually inside of Oracle, and then you can have it evaluate a compartment, and you could create a Terraform stack from what's actually running there. So if you already have resources running, there's a way to actually go in, evaluate what's running, create a stack, evaluate that stack to make sure it's ready to go. But you can now, basically go from manual to automated, and then you would be able to replicate that somewhere else. So there's a lot of benefits to utilizing this, no matter where you are at in your journey of getting to automation.
Yeah. And that's a great point to make, Larry, because a lot of our customers have started their journey and didn't get off on the automation foot right off the bat. So this really makes it so that it really is never too late to start doing it the correct way. And that's something that's really nice about Resource Manager. So I'm going to, let's see here, share this screen. If I select the correct one. Yeah, here we go. And so I'm in the console. One thing I want to show everyone here is the demo that I'm showing is available publicly on our reference architecture site. It's actually called Architecture Center, that has tons of resources for operations, for application development, for best practices that I'll show here. And in most of the cases, they have code just like this that you can deploy into your environment using Resource Manager, or you can go to the GitHub repo and download the code to test it out yourself. But again, taking advice from Larry, which is good advice, before you just go clicking and installing, make sure it does what you think it does and is not negatively affecting anything else in your environment. This one particular one that I'm gonna just click on today, it takes advantage of a new feature that we have within DRG. It's our DRG v2, which allows multiple VCNs to be connected through a single hub, sharing a fast connect. I want to spin this up in my environment to take advantage of that. So I can do two things. I can click over here and go to GitHub and actually view the source code that it's running, and download it, see the exact execution steps that are being done. We have some good documentation that walk you through it, and you can run it from either your build server or your laptop. But what I'm going to do today is the other really nifty tool is you can deploy it to Oracle Cloud using Resource Manager directly from these instructions. And it takes me directly into my account, which I've already logged into. It doesn't do any magic. I did the previously prepared way of getting into my account, but I accept the terms that say, this is a demo, and it builds out the parameters just like it's taking the code from GitHub, and it starts building out the parameters that you would as if you're running it on-prem. I'm going to say on-prem, on your own laptop or on your own build server. So I'm going through selecting some of these parameters. Same way this is what I'd be providing in the Terraform code, but it handles it all for you. And within Terraform, there's this idea of running a plan, which is basically a dry run, or running apply, which creates all the resources right off the bat. And it assumes that you know exactly what it's going to do and you're ready to go. So I'm going to just go ahead and run apply because I've run this before and I know what it's going to build out. And so what Oracle is doing for me is this build execution. It has a build server running that's going to execute this job that I requested, and it's going to build out this infrastructure that I've defined right here. So while that's doing that, I want to show one thing that that Larry mentioned. With the resource manager, you can create stacks, and I'm going to click through here, and it's going to give me an idea of existing compartment as a target. This is something he mentioned, and he brought it to mind, and I don't know why I didn't mention it in my part of this, but it allows you to actually select a compartment that you've built out with resources in it, and it'll actually go out and profile that compartment, profile those resources, and then retroactively build Terraform to describe that. So that if you make any future changes, if you want to add resources, if you want to add security lists, things of that nature, and you want to do it in the correct way through automation, you can continually do it through Resource Manager, and you have all of that code in place that's traceable and auditable. So that's just, like I said, you can click through it here and take advantage of that right now. But I'm going to go back to the job that I submitted, and let's see if we're still in progress. And we can actually see this is what Terraform would look like if you executed it locally, and we have the log and the output. Now, what if I had not wanted to do this? Or let's see, I'll pause here. Larry, does this make sense to this point? Are we clear to as far as why this is beneficial and how we could why we would do this as opposed to something else?
I think so.
Yeah, so and we'll get through here in a few more minutes, and it's not going to take very long. It's building out those resources. I'll actually click over and see if,
yeah, Jeremy, so this right here, so everybody that's seeing the logs here, I think this is something that's, definitely a beneficial piece, because this is going to show you, when you started creating this, there's two ways to actually launch this job. We kind of talked about, there's the plan. So before you even run a job, you can actually click plan. It will go through and tell you what resources are going to be created, modified. It's going to give you kind of a state file essentially of what things are going to be. I lost your share there.
Oh, there we go. I was switching over to kind of accent what you were actually saying. So so let me do that here. Let me clear. Can you see my screen here? It should be some boring code. I know this is deeper in what we go sometimes in these talks, but I think it illustrates the idea of this is
zoom in a little bit.
Oh, yes. I believe I can.
There we go. Make it a little easier to see.
Yeah, there we go. And so this is the code from a job that I ran just previous. And let's say I wanted to make a change. We're a company and we have a sale coming up or something of that nature. And you'll see that I'm actually defining my infrastructure through these variables. But if I want to make a change and I want to say that I want to increase my my CPUs because we have an influx of traffic that we're expecting over the next few weeks. Let's say it's about to be Black Friday. I can change this now. I would change this as an ops developer, as a DevOps developer. I could save this, and I would do my get commits and here and go through the proper circumstances. But let's say I wanted to, let's say I've done all that and everything's cool. I can check to see, hey, what is going on? Does this conflict with anything in my current environment? And this is that Terraform plan that you were talking about. So it's actually checking against the state. And this is the plan. So it's not actually making these changes, but it's telling me, hey, this is, if you actually execute this, this is what will happen. You're changing the instance count, the CPU count from 1 to 3 on this instance that you've defined. It's going to change one thing, destroy nothing, and plan. So this is something where this is the first level of testing where I can see before I even make a change if it's conflicting with another resource, what it'll look like when I execute this. And then finally, give me the opportunity to actually execute it. So I'm going to do that now. And it's going to ask me, am I sure?
One thing to notice, like this, so what you're running this in is just using like an IDE. You're using
Yep.
which IDE are you using?
So this is just Visual Studio Code. It's free
Yeah.
and it's my comfort level. So yeah, it ran the plan again. It's telling me it's going to change my shape. I tell it yes. And now it's going to go out and we can actually go out and see through the execution.
And this is a great way to run it, but then, the state file control and that portion, I think that's one of the other things why we look towards
Yeah.
like Resource Manager or having a central repository, because if Jeremy makes a change and then I go in and make a change, I have to make sure I'm using the correct state file, the current design of what's happening here. So that's something that you do have to consider those things when you start using automation tools. Is when I make a change, I need to go into that tool and make the change. If I go and make a manual change, I can pull that in to Terraform to look at what's going on, but I do need to control that as we build it out.
Yep. And as you can see, when I executed that, I'm looking in one screen. Actually, I should probably share the whole thing, and that would let you actually see what's a better execution of what's going on. There you go. So yeah, on the left, I hope you can see it pretty clearly. You can see it's executing the stop and update, and on the right, you can see it actually inside of the console reflected where it's stopping the VM, the Bastion VM that was described, and then it will be adding the CPU count once it's stopped. And once it's stopped and restarted, it happens pretty quickly. But again, it's safe. What it's doing is it's draining any connections. It's safely bringing it to a stop, and then it'll restart it again. This, for one server, this doesn't seem that grand, but I challenge you to think of this as a fleet. If you have a Kubernetes cluster of a couple of dozen servers and you want to update them or change the configuration on those servers, or even if you want to patch an entire region worth of servers, changing the patch version in one place and saying roll this out in a certain way is so much easier, so much more controlled than it would be to go to each individual server and execute the update scripts. Or even if you have a centralized update provider, something like a Capsule or a Red Hat solution, you still have to go in and provision each of those instances with the versions that they expect and that they are striving towards. So with this, you manage that all centrally, and you can categorize them, you can group them, and it gives you that power to do it all from one location. As you can see, as I was speaking, it stopped, it added my CPU count here, and we're back up and running.
And continuing on that thought process, Jeremy, I mean, the power that you have here, everything that Jeremy's doing with Terraform, it's still tracked. Like, we still have audits. We still, like, this is an API call that's happening on the back end. So it's still going to be tracked of, who's doing what, because you still have to have permissions to be able to run the Terraform, so we can create policies around that and have our security in place. We can also have notifications that something has been modified. You can have rolling updates that are going to happen. You can have in Terraform where it has a dev, test, and prod that gets deployed. And if I make a change, I want it to change all of them, and I want to change it in a certain order or certain procedure. That's all stuff that can happen by utilizing this. And you'll see, you have the monitoring that is on the bottom. So you have the CPU utilization, memory utilization, disk IO. All of these can be viewed in another location. There is a central monitoring page that is easy, maybe a little easier, and then you can also create the alarms. So that's one of the other things that we were talking about, is monitoring and learning. All of this can be done either from the console or from Terraform. And so if Terraform does not have the direct syntax to do it, that doesn't mean that you can't automate it with Terraform. What you would have to do in that case is you add a script that gets pulled in. That script will run to take care of that particular piece that may be not a, normal syntax at this point for Terraform. Because maybe it's a new service that got launched and Terraform's going to have full support for it in their next version, but you can still script it out and do that. So like when you're launching an instance in the console, you can pull in a Cloud Init script to actually configure it. So there's a lot of stuff that can be done by utilizing Terraform, and still have the monitoring, the alerting, the control, the consistency. And I think the biggest thing that I get out of this, especially when we're talking about operations and talking about mass deployments, or even if we're doing a small 3-tier architecture deployment, is the consistency of it. Because that is going to be the difference between an application running successfully and having long-term issues. And it also makes it easy. The biggest thing Jeremy was talking about that I agree is you can destroy it. You can destroy it with a click of a button. Now, and that could be terrifying, but it's also the benefits of being in the cloud. It's the benefits of using infrastructure as code, because if we roll out, you start thinking about the ideas of, if we have to roll back quickly, how do we do that? If we don't have any automation in place, how do we roll back? Well, it's very difficult. But if we have automation, if we have Terraform in place, and there are lots of other automation tools out there. We talk about Terraform, we talk about Ansible, and Ansible is another product that you can utilize in conjunction with, because Terraform is your infrastructure as code, and then Ansible is going to be your package management, your internal inside of the OS configuration and keeping everything where it should be. Because Terraform doesn't look inside your OS. So that's kind of the next level that you have to consider in kind of this process. Terraform will check, confirm where a resource is at, what it's, what it looks like. Does it follow that Bastion VM that Jeremy's deployed? It does. Cool, it's deployed. But if you want inside the OS, that's where we start thinking about another layer on top to work in conjunction with. Anything that I missed there, Jeremy?
No, I was gonna say I could hear through the interwebs a lot of. I thought this was an operations talk. This is this seems like you're spending a lot of time on Terraform, or you're spending a lot of time on infrastructure as code, and that is true. And it is because when you think about operations, Quick Start is the basic foundation of operations. Our best practices, Oracle's best practices, cloud's best practices are automation for security, repeatability, and manageability. That's where everything has to start. So if you want to establish a proper tagging solution so that you have visualization, the best place to start that is in your automation, in your scripting. If you want to have concise, efficient monitoring of your environments, it has to be at creation time and linked and integrated using your automation and using your scripting. If you want security, you can't have people with their fingers all in your environment, all in your console. It's got to be through automation. It has to be through infrastructure as code. So that's why we really base this on as the foundation for operations, is because the cloud, I'm going to say the cloud operating model for all of operation has to have infrastructure as code, configuration as code as one of its chief facets, so that you can scale with the cloud, so that you can keep it secure and keep it efficient. So your developers are developing and you're constantly innovating inside of your cloud environments. So that's what that gives you. So that's the only thing I'd really put forward. I know in a couple of our past talks, I tend to lean more towards that development, lean towards that low code mentality, but it's where that the concentration on the fundamentals gives you the ability to have the fun in the cloud, to do the scaling, the auto correction, the auto recovery type situations for your environments, so that you don't have these freak out moments at 2 a.m. Oh, my automation can handle it until I'm ready to address it. So that's where this is based in. So that I'll say that was, I don't know if you missed that, but that's what I wanted to get across.
Yeah, I think that's a very valid point. I mean, it leads back to one of the resounding things that when you become a sysadmin, I'm a lazy sysadmin. I mean, I want to make sure that I can sleep in. I want to make sure that this stuff is taken care of. So you can sit on a beach sipping a Mai Tai and saying, I got a notification, everything's working great. Because the automation that's built out around it is functioning the way it's supposed to function. And it is from a security standpoint in the current status of how things get deployed. If you don't have Terraform, and something fails, how do you recover quickly? This goes back to another part of the journey, not only in operations, but this is how things kind of mesh together when we're talking about the different personas in the industry, is the RTO and RPO and recovery time objective, recovery point objective. And Terraform is definitely going to accelerate that process, especially if you have like a backup and restore model. You can still have Terraform ready to go to build out the infrastructure. If you need to scale, it's a matter of going into the Terraform and making a quick adjustment and having that, increase. And this is something that if you're new to Terraform, this can be done all with Resource Manager. So if we go into, Jeremy, since you have Resource Manager open, do you mind going and creating a stack real quick?
Oh, yeah. So let's see.
And if you can make that screen a little bit bigger, it might be a little easier to see. Yeah.
I'm going to hop over here real quick.
I know we're coming up on time here, but we'll take a quick glance at this. But so when you go to create a stack on Resource Manager, there are, go in there, create stack. So we have templates. And this is something, if you have a new account, feel free to try some of these templates. And I know they're very basic templates, but if we click the drop down on the right, this is the arrow next to, the arrows on the right there, or the architecture. Yeah. It gives you a brief description of what's going to happen here. But before you even deploy these, you get the option to do plan. And plan will actually tell you what's actually getting launched in this case. There are different architecture files you can pull in from the Architecture Center, and different versions of Terraform. And this is all something that you can download this, you can take it away from here. And like Jeremy was using, he was using an IDE, which I like IDEs because it will at least check my syntax, or it checks the Terraform syntax. It may not check that that's possible with Oracle Cloud, but it'll check the syntax to confirm that portion. And then I just have to make sure, I could do that. And when I first started learning Terraform, I did not just go sit down and write Terraform from scratch. I went and found Terraform scripts and I pulled in some of the information I needed to kind of get it started. So it's something that will definitely help in this process. So, but when you can download the Terraform configurations, and we can run it and we can destroy it. It'll give us the variables, it'll give us the outputs. You can define what outputs you're going to get in Terraform, but that's going to help in this journey. So, yeah.
And it's all right. It gives you that same, like I said, to reiterate, it gives you that same customization. You're not missing anything. The one thing, there we go. And so that was the plan. We can actually go back and, like you mentioned, this is what it's going to do. And you can look through here and see exactly what it's going to create. We're going to create a data warehouse. And again, to get kind of down in the weeds, gives you, ability to name it, your password, all these, you can actually hide it because this is something Terraform will do for you. It's not going to just print it out in logs. So all the configurations you can do, one, if you're setting it up with the SDK, if you're setting it up through the environment or the console, you get even a little bit more fine-grained control when you're doing it through Terraform. Once you've validated this, there's a lot of tools out there to actually take in Terraform plans and validate them against standard and practices, against security requirements, so that you, through your automation, if this is a build server building it, it says, okay, here's what a developer or a DevOps engineer submitted to be changed or created. Does it meet our naming conventions? Do they have the proper security constraints? Has it been gone through the correct channels and approvals? If so, if all of those things are met, then and only then will we execute this code. So you have all of that ability in through automation, monitoring, and almost immediate feedback to the developer, so that if there's an error, if they had a typo, or if it doesn't pass muster, then they can make those changes in code, resubmit the change, and have that feedback back and forth, instead of a ticket being put into ServiceNow or another ticketing system, and then an engineer having to take time to go themselves perform the change only to see that it doesn't work. So you have all this back and forth that could take days. In my experience, past companies I've worked for, even weeks to get a single change made. This can happen over a matter of minutes. And so that's what this buys you. And the other thing I'll say this is the state, the idea that if I make a change here, if I apply this, make a change, it keeps up with the way it should look like. Back over, if I ran it locally, I could actually switch over really quick. I know we are running close on time. But if I switch over and say, what is this supposed to look like? It is now my responsibility to keep up with this here. This is that Terraform state file that describes my environment. And so this is just another benefit that Resource Manager gives you, in that it keeps up with the state file. Now, in production, this should be in Object Store and OCI. It can be kept in other centralized places like in the NAS or something like that. But it's something where, given the state, you know what your environment's going to look like, you know what it should look like. And if something goes wrong, you can roll back to it, you can roll forward to it. Resource Manager also manages that for you. I know we're running short of time, so is there anything else, Larry, that we want to address?
I think that covers the topic of operations
Awesome.
today. I think, just to kind of recap what we covered today, we talked about, one, the shared responsibility model, and the fact that you're dealing with your application when you start getting into infrastructure as a service. Infrastructure as a code is going to help simplify that process, and simplify the process of utilizing cloud to its full advantage due to this scalability of it. So you can go from region to region, especially with having Terraform. And it just makes, it makes it easier to deploy your monitoring and all of the other aspects that we talked about today. So thank you all for joining the Day One and Beyond. And Kenna, back to you.
Excellent. Thanks so much, you two, for this fourth in our 6-session series. For those of you still with us, I have a poll popped up there if you want to give us your ending thoughts. We always appreciate your feedback very much. We do have 2 more sessions of this particular series coming up, so we hope that you can join us for those. And come over to the forums and check out some other upcoming events, post some questions for discussion, anything that comes up as you start to play with Terraform or Resource Manager. There are forums and discussion threads for all of those things. So feel free to go and investigate and dig some more, and reach out if you ever have any questions. So thanks so much to Jeremy and Larry. Thanks for everybody for joining us today, and we will see you next time. Have a good day, everybody.